Hi, welcome everyone. Welcome to my talk about the future of JavaScript bundlers. Yeah, I'm Johannes, and I founded a company with my friends. It's called Perigon. We are based in Augsburg, that's next to Munich. And I'm also a member of the Webpack team. And as a short disclaimer up front, the opinions in this presentation are my own, and this is not a statement from the Webpack team. And on the next slide, you will know why. Because my question is, do we even need JavaScript bundlers? Because let's be honest, we don't really want to use them. Don't tell Sean that I said that. Because there are a lot of problems with JavaScript bundlers. Because suddenly the web needs a build step. It didn't need it before. And there's configuration hell. It can be really complicated to configure it. And basically, the code you write is not the code that is executed. And then you have to figure out how source maps work and configure them. And you basically have to deal with problems you didn't have before. And there's a good reason that we ask, do we even need JavaScript bundlers? Because we have JavaScript modules in the browser. And the most recent browsers support it. So yeah, why not use them? So why isn't everyone just using Css modules? It's because of this error. Failed to resolve module specifier, lodash, whatever. That's because this hasn't been specified yet. You can only import relative paths. And this breaks like for all NPM modules, because when we're using NPM, we need these module specifiers. So we have no bare module specifiers, but we also have no file extensions. No optional file extensions, so we have to use the file extension. And there's also no package JSON resolving. So there's no switch we can do between like node code and browser code. But the question still remains, like we are going to solve that probably, but do we still need JavaScript bundlers in the future? So let's talk about the future of JavaScript bundlers. But before we talk about the future, let's think about what's the purpose of JavaScript bundlers today. Because in the beginning, it was about giving JavaScript modules into the browser, so it's about dev experience. But after that, we also started to add other module types like HTML and CSS, and now we also have WASM modules. And since we had a build step, we could do anything. So we invented custom languages like JSX, TypeScript, Vue files. But we still wanted to have this short feedback loop. So bundlers also invented things like hot module replacements, so that you can, for instance, work on styles. But there's also this compatibility aspect. The bundler unifies the module systems. So on NPM, we have CommonJS, we still have AMD, we also have ES modules, so the bundler unifies that. It unifies also the platform. So a lot of modules are using Node.js core modules, and these need to be shimmed for the browser to make them work. And we also use bundlers, or at least use bundlers to orchestrate Babel, for instance, that we can translate new language features to older language features that older browsers can also understand our code. And as last aspect, there's also this optimization. So we do optimized resource loading, which means, for instance, that we merge different JavaScript modules into a single chunk to avoid HTTP requests. But we also add resource hints for the browser to discover additional resources. We do long-term caching, so we add a hash to all file names, and so that we can cache them for a very long time. And we also want to reduce the final file size. So this is about minification, tree shaking, and all that stuff. So in the beginning, we used bundlers just for JavaScript modules, but then there were a lot of new other features that came. And as a heads up, I'm going to show some new proposals but they are in a very early stage, so please take them with a grain of salt. It's just like, I want to show you where the direction is heading. Don't use it like tomorrow in your production app. So let's talk about JavaScript modules. And as I already said, we don't really need JavaScript bundlers for that, because now we have ECMAScript modules and everything is fine. But our current problem is resolving, as I just said. So things we can do, not rely on cute resolving features like Ryan Dahl said it in his talk. So we should use file extensions. We should use the m.js extension for JavaScript modules once ESM lands in Node.js. We should avoid index.js. And I think we should also avoid module aliases just for ergonomic reasons. And that's because the browser can't do all these lookup, because it has to do several round trips to do that. Just use the real path. I really like that one. But do we really have to give up bare module specifiers? And these are like when we just import something from Node modules. Because there are several advantages of bare module specifiers. Of course, like there are shorter imports for common packages, but there's also this indirection at package level, which allows the main browser switch. So for instance, for isomorphic fetch, this is really important because it can switch the implementation. And they also hide the actual file layout of third-party modules. But luckily, there's this import map specification, which allows us to add an import map so we can map from a bare module specifier to a URL. And the good news is there's an intent to implement from the Blink team. They released it just yesterday. OK, let's talk about HTML modules, CSS modules. So there's this HTML module proposal, and it is meant as a replacement for HTML imports, and it looks like this. So you write your HTML file, and then you can import the HTML file and call a query selector, for instance, to get the DOM element. But you can also export like other values. So it kind of reminds me of Vue files. And I think it's really cool. And there's also an intent to implement from the Edge team. Then there's this CSS module specification, where you can also import CSS files, and they export a constructible style sheet. Then you can add it to the shadow root, for instance. And there's also this idea of like exporting symbols, class symbols that you can use in your HTML. Then, of course, there's this proposal for JSON modules. And there's also a proposal for WASM modules. And the goal of the WASM module proposal is to turn this imperative API, where you do a fetch, and you have to wire up all the imports, and then you call instantiate streaming, that you can turn this into a declarative API, where you just import the WASM module. But the challenge here is to allow cyclic dependencies between non-JS modules. So here we have a cyclic dependency, and yeah, that's really hard to integrate with ECMAScript modules. And probably cyclic dependencies between two WASM modules won't work at all, but that's still being spec'd out. So what about custom languages? In 2016, there was this loader specification where people collected interesting ideas how we can transpile things in the browser. But they stopped working on it and broken down it into smaller pieces. So that's where, for instance, this system.import came from, which later just became import. and we are already using it today for code splitting. So there's this asset references idea where you import assets, and you just say that for instance, I have a logo. It's here, and then with this reference, you can pass it to, like, for instance, the create object URL function or any other loader that is able to transform that asset into something meaningful. There's also another interesting proposal where you import something and then you specify how to transform it. This is not a popular proposal, and it has no champion yet, but I really like it. So maybe we can push it into to that direction. And the advantages of these proposals is that there is no out-of-band configuration of loaders. So you don't have to configure somewhere else how to import stuff. Modules determine how they want to import a dependency. And this means that there's also a custom language support for NPM modules. Now sharing front-end components would become easier. And I think then we're one step closer to zero config. One thing to note, these proposals do the resource transformation on runtime, but you probably want to move it to build time in production to get it really fast. So one constraint, at least for me, for these proposals is that they should be statically analyzable. But this kind of figuring out how these loaders work is really hard to standardize because bundlers, Node.js, and browsers have very different requirements. So there's no really a common agreement how to do that. But there's also an interesting alternative to loaders, and this is Babel Macros. So Babel Macros is a Babel plugin that allows you to evaluate code on build time. So for instance, there's this preval macro which executes the code that you pass in. And for instance, in this example, we evaluate the calculation, export it, and then this code is evaluated on build time, and it just inserts the final result. Also, the import is removed. So this is another example where you could have readable durations, and it's translated on build time. But how can this substitute loaders? So, for instance, you could use it as a substitute for the raw loader. You import the macro, you call raw and whatever file you want to import, and then it replaces the call with the contents of the markdown file. And this is another example, and it demonstrates why it's really good to have that the module can specify how to transform the resource. So in this example, there's this image JPEG, and I want to have it as a object URL because I want to display it, but I also want to have the image size because I want to avoid layout reflows during load. And I don't want to hard code the sizes because they might change. So in this example, it's really valuable to have these two macros and work on that resource. But how would that work without Babel? And the idea is that you could have a package switch of the macro. So during build time, it uses the main module, and during runtime in the browser, it would use the other implementation. But the current problem of Babel macros is that they require synchronous I/O on build and on runtime. But maybe that can be solved. And the last feature is the short feedback loop. So when we do not have a build step at all, and we can do the transformations on runtime, it will be a lot easier, and we get this short feedback loop again. We just need to find a way to make the transformations cacheable, because otherwise loading the application would be very slow. And for hot module replacement, we would still need a dev server with WebSockets, so the server notifies the browser that there has been something changed. So now we've talked about the dev experience. Let's talk about the compatibility aspect. And I think regarding the module systems, that authors will slowly adopt the common denominator. That is ECMAScript modules, imports with explicit file extensions, and using the MJS file extension for ECMAScript modules. And then bundlers won't be necessary because of compatibility reasons, which is really good. What about the unified platform? So my hope is that platform-independent APIs will converge someday. So for instance, there's this good example of the URL constructor. Now you can use the URL constructor in the browser and in Node.js, and it just works. And it makes sense that this API works in both platforms. A bad example, at least now, is fetch, which doesn't work in Node.js, and personally, I don't see the reason why it should not work. So I really hope that they figure that out. And there's also this standard library proposal, which would slowly extend the JavaScript standard library. And Daniel Ehrenberg from the TC39 is like waiting for your feedback. So if you think that would be valuable, please let him know. What about new language features? I think that it will be probably less relevant with evergreen browsers and incremental language updates. So we had this huge language update with ECMAScript 2015, but I think now we get features more slowly and not like this big change. But we will probably still need to transpile it for production builds to support older browsers. And also polyfills still require a lot of manual configuration. So one idea would be like automatic polyfills. What if library authors annotated what polyfills they need, like this? Then the bundler could figure out what polyfills need to be included depending on the target. So we talked about the compatibility aspect. Now let's talk about the optimization aspect. Optimized resource loading. And the elephant in the room here is, should we even create chunks with ECMAScript modules and HTTP push? And for those who don't know, HTTP push is a new feature that allows the server to push resources proactively to the client. And there's no clear answer yet, and many factors need to be considered. So that would be a whole another talk, so I'm just going to cover it quickly. But the current problems with ECMAScript modules and H2 push, browsers haven't optimized native modules yet, so they're kind of slow, but hopefully that will get better. But we also have inconsistent HTTP push implementations, and pushing resources that the client already has cached is worse than no push. So we also need to figure that out. And text compression algorithms like gzip are more effective on bigger files. In general, HTTP push is still hard. And so Google engineers published a document, it's called Rules of Thumb for HTTP Push, and I really recommend it if you want to use it. But as implementations mature, we need to re-evaluate the question whether we should create chunks or not. But let's assume that we really, really want to use HTTP push. So how would it work? There are two possible solutions. We could use an empiric approach, like the Node H2 auto push module does it, and it tries to learn what to push by observing client requests. Or we could use a bundler which generates a dependency graph on build time and pass that result to the HTTP2 server. But creating a dependency graph for the HTTP push server is not the only performance optimization a bundler can do. But the current problem is that getting the best performance requires a lot of configuration. The solution: give more data to the bundler so that it can perform automated decisions. Now, I'm going to give you some examples. So the first data source would be static analysis. So the bundler could add resource hints automatically, like pre-connect, for all hosts that have been parsed from the source code. And this already works. You can add Webpack prefetch to add a prefetch resource hint for another chunk. And maybe we could also do something like that we add Webpack preload to render critical fonts. This doesn't work yet because it doesn't work for CSS files, but technically it could work. But these manual hints can get outdated over time. So there's this other data source. We could use automated critical render path tests. And the idea: there are automated tests that navigate to popular routes, and the bundler captures relevant performance data, and then the bundler decides which resources to optimize and to prioritize. So for instance, we could create optimized subsets of fonts based on the actual usage of glyphs. And there are two packages to help with that: subfont and glyphhanger. And another example, we could inline render critical CSS, and this is already a popular feature of CSS and JavaScript libraries. And you can also use critical for that. And I think this running automated critical render path tests works especially well with the Jamstack, where you run the build each time something of your data changes. But these automated tests are also error-prone because we have to select the popular routes. What if instead of artificial usage data, we used real usage data? And I really like that. Did I say that? So the third example I want to give you is that we could use analytics to drive our decisions. And this is called data-driven user experiences, when real usage data drives the decisions about how to optimize the app. And this is already possible today. There's this Webpack plugin. It's also a Webpack plugin and a standalone module. It's called Guest.js. Has been announced at Google I/O. And it uses real usage data from Google Analytics to decide which chunks to prefetch next. And it also uses probabilities combined with the effective type, like the network type, to avoid overfetching and thus wasting expensive data on mobile. Then there is long-term caching. And I think calculating content hashes and updating URLs will always require a bundler because you don't want to do that by hand. But there's also another problem. In order to avoid propagating content hashes, we need to use an out-of-band configuration. And that sounds, I know that it sounds strange, but I'm going to explain it. So in this example, we have two modules. One is importing something from something, and it exports something else, and the other module imports it. So what if, like the first module, the something module changes? Then we have to update the hash in the URL, and now the content hash of that module changes as well. So a single change invalidates all content hashes. And we could solve it by not using hashes in import paths, and we could remap the imports via import maps. I'm not sure if that would work with the current proposal, but that's how we could solve it. Smaller file sizes. And all these optimizations will still be necessary in the future. Tree shaking, dead code elimination, minification, and compression. So this is the reason why you will always have a build step for high-performance websites. So my conclusion, in the beginning, bundlers were invented to use Node.js modules in the web, but this has changed. Today, we use bundlers for a lot of reasons, like dev experience, compatibility, and optimizations. Will we still need bundlers in the future? And to answer that question, I've marked all the features that we currently use with 3 kinds of dots. The green dot means that the bundler is not necessary in the future. The yellow dot means that the bundler is probably not necessary, but it's hard to predict. And red means that the bundler will still be necessary, at least for production builds. And you can see that especially the optimization features will still be necessary in the future. And that's because bundlers can do stuff on build time that would otherwise need to be done on runtime. And that's something that won't change in the future. But the scope of bundlers will probably change. So my vision is that bundlers should not be necessary because of compatibility reasons. They should not be necessary to allow us to write the code the way we want it. They should only be necessary to make our apps fast. And in order to make that happen without configuration overhead, we need to give bundlers more insights into our application via static analysis, via automated critical render path tests, and via real usage data. Thank you.